Hello everyone, my name is Thanika Promchai. I'm a PhD student from Chiang University, Thailand. Today I would like to present some part of my research in the title of Flavonoid and Flavonoid glycosides from the leaves of Anomianthus dulcis. Anomianthus genus has a synonym as UWRC genus. It belongs to Anomianthus family and distributes along tropical and subtropical Africa, Asia, and Australia. In Thailand, it was found around 26 species as shown in this slide, and there are 5 species that were investigated their chemical constituents and bioactivities, such as UWRC cherobensis, Anomianthus dulcis or UWRC dulcis, UWRC hamiltonii, UWRC rurida, and UWRC siamensis. And today I will show the investigation of UWRC dulcis or Anomianthus dulcis. In 1998, Sims and co-worker reported the isolation of acetylcholine and 14 alkaloids from the stem and leaves of this plant. 1 year later, the same researcher reported 3 known flavonoids and dihydroxyalcohol together with a phenylpropanolamide from the leaves of this plant as well. In 2001, Janhaproma and co-worker report the derivatives of charcoal as shown in this slide. In 2014, Bonopas and co-worker report the isolation of ethanol crude extract from stem bark. They found 3 known flavonoids and 2 known alkaloids. From here, the alkaloid, namely rhodonine, show the best cytotoxicity against lung cancer cell and herpes simplex virus type 1 with this IC50 value. In 1 year later, Kavidrapop and co-worker report 2 new polyoxygenated cyclohexene with long-chain hydrocarbon, and they reported from the methylene chloride crude extract of Thanika. So, in my research, I would like to investigate the chemical constituents and bioactivities such as anti-malarial activities and cytotoxicity against oral cavity cancer cell line or KB cell from the leaves of Anomianthus dulcis. Anomianthus dulcis is a woody climbing plant. It has an oval single leaves. The flowers has umbrella-shaped with yellow color, as shown in this picture, and it produces green aggregate fruits. In traditional medicine, it was used as a fever treatment and galactose cocoa in Thailand. We collect this plant from Chiang Mai province in 2017, and it was cut and dried at room temperature to get a dry leaf around 350 grams, and then extract these dry leaves with methanol 15 liters 40 times, and it gave the methanol crude extract around 76 grams as a dark gum. And this crude extract was separated a small amount to test the activities with the malarial strains and KB cell line. It showed that this crude had a good cytotoxicity against KB cell line with IC50 value less than 1 microgram per milliliters. The methanol crude extract of leaves was separated by using quick column chromatography with this gradient solvent system. It led to fractions A to R. Fractions C, G, H, and R were selected to isolate with the appropriate chromatographic techniques. The isolation of fractions C, G, and H provided 3 known flavonoids and a known flavone. These flavonoids show the characteristic proton NMR of an oxymethyl proton at around 5.4 ppm and the diisomeric methylene protons at position 3 at around 3 and 2.8 ppm. Moreover, it showed the symmetric metal couplet aromatic proton of ring A about 6 ppm and the monosubstituted benzene ring of ring B around 7.4 ppm. So, in compound 1, it was assigned as pinosembrine. while compound 2 shows the additional group of 2-hydroxybenzyl group and methoxy group that located on carbon position 8 and carbon position 7 respectively, and it was named 7-O-methylchamanethane. In compound 3, it shows similar pattern proton NMR to compound 1, but there was a methoxy group instead at carbon position 7 and was named as pinostrobin. And this flavone, it shows similar proton NMR to compound 1 as well, but the carbon position 2 and 3 were changed to an unsaturated alkene and presented as a synchronous proton at around 6.8 ppm. In fraction L, it was isolated as shown in this figure, and it provided 4 non-flavonoid glycosides that I will present their structural elucidation in the next part of discussion. To assign the absolute configuration at carbon position 2 of these flavonoids, they were analyzed by using the specific rotation values comparing to the reference. From this, the specific rotation values of compound 1 and 3 presented in high positive values, while compound 2 show nearly to 0. When compared their specific rotation to this reference as shown, it was found that compounds 1 and 3 were assigned as a configuration, while compound 2 was assigned as a racemic mixture. Now, I will show the structural elucidation of flavonoid glycoside that start with compound 7. The proton NMR of compound 7 show the characteristic pattern of flavone and glycoside. The flavone show a set of 1, 2, 4 trisubstituted benzene ring of aromatic ring B with these chemical shapes with a meta-coupled aromatic proton of aromatic ring A, but there was no signal of proton at position 3 of ring C. Moreover, there were 2 sets of saccharide as shown that show 2 anomeric protons at chemical shift 5.1 and 4.5 ppm, along with the characteristic methyl protons of rhamnoids. From the carbon NMR of compound 7, there were 27 carbon signals, including 15 signals of flavone and 12 signals of glycoside that can indicate that there were 2 groups of pyranoses. Moreover, the 2D NMR such as COSI, HMQC, and HMBC were used for characterizing these pyranoses. It showed that these pyranoses were assigned as glucose and rhamnose. The anomeric proton of glucose presented at 5.1 ppm as shown, while the rhamnose presented at 4.5 ppm. And the other protons were assigned their location as shown in these figures. From the HMBC correlations, the anomeric proton of glucose show correlations to carbon position 3 of flavone, while the diastereomeric proton at position 6 show HMBC correlation to anomeric carbon of rhamnose, so there were 2 glycosidic bonds between carbon position 3 of flavone and anomeric carbon of glucose and carbon position 1 of rhamnose to carbon position 6 of glucose as shown. So compound 7 was elucidated as quercetin 3 or rutinoside. The next compound is compound 6. The proton NMR of compound 6 show similar pattern to compound 7 that consisted of flavone, glucose, and rhamnose, but the pattern of aromatic ring B show a set of para-disubstituted benzene ring instead of 1 to 4 trisubstituted benzene. And so compound 6 was characterized as camphorol 3 or rutinoside. The next compound is compound 5. This compound shows the proton NMR similar to compound 6 that consisted of a set of camphor flavone, but the proton NMR splitting pattern of glycoside were shifted. That means the configurations of these positions were changed. From the 3D NMR of compound 5, it showed that the configuration at carbon position 4 of glucose was changed based on the Rossi correlations as shown in this slide. So, the glucose was changed to galactose in compound 5. So, compound 5 was elucidated as by this name by Hu and co-worker in 2005. The last compound is compound 8. The proton NMR of this compound shows similar pattern to compound 5 that consisted of the flavone, galactose, and rhamnose, but the anomeric proton ring B was changed to B124 trisubstituted benzene ring. So compound 8 was characterized as this name by Laurent and co-worker in 2005. In conclusion, the investigation of fractions C, G, H, and L from the methanol crude extract of leaves from Anomianthus dulcis led to 8 known compounds such as 3 flavonoids, 1 flavone, and 4 flavone glycosides. These flavone glycosides were the first isolation from this plant, and unfortunately, none of all compounds show bioactivities against malaria strains and KB cellulite. Thank you for your kind attention. Any questions are welcome.